Hello everyone, welcome to Rare Chem Official. This video is about atomic radius. If you like this video, please like, share and subscribe. Without delay, let's get started. Atomic radius. The distance between the nucleus and outermost electron is called atomic radius. If take an example, hydrogen, the electronic configuration is 1s1. If the valence electron is 1, the distance from nucleus to valence electron is called atomic radius. If you take another example is sodium, the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. Sodium, the first shell has 2 electrons. Second shell has 8 electrons. Two, 3, 4, 5, 6, 7, 8. The outer valence shell has 1 electron. The distance between nucleus to valence shell is atomic radius, right? In general trend, atomic radius increases from top to bottom. Across the period, atomic radius is decreases. In general trend, the atomic radius is increases from top to bottom. From left to right, atomic radius is decreases. Why? Because let's look some examples. Take lithium. The atomic number is third, 3. The configuration is 1s2, 2s1. The first shell has 2 electrons. Valence shell has 1 electron, right? Carbon atomic number is 6. Electronic configuration is 1s2, 2s2, 2p2. First shell has how many electrons? 2 electrons. Second shell has 6 electrons. If you take one more atom, oxygen atomic number is 8. Electronic configuration is 1s2, 2s2, 2p4. First shell has how many electrons? 2 electrons. Second shell has 6 electrons. Here in carbon, actually second shell has only 4 electrons, but I written 6 electrons, sorry for that. Oxygen has 6 electrons in outermost shell. If you take one more atom is fluorine. Atomic number is 9. General electronic configuration of fluorine is 1s2, 2s2, 2p5. The first cell has 2 electrons. Second cell has how many electrons? Electrons 7. 2, 3, 4, 5, 6, 7. Atomic number equals to number of protons equals to number of electrons. Here if we observe, atomic number lithium is 3, for carbon is 6, for oxygen is 8, for fluorine is 9, right? But increasing the atomic number, but number of cells, how many we are here? We are atomic number is increasing, but number of cells remains constant, right? Here if we observe, how many cells has present? 1, 2. Here also 1, 2. Here 1, 2, right? In fluorine also has 2 cells only. So if we observe, here we conclude that from left to right, atomic number increases, but number of cells remains constant. That's why atomic radius is decreases from left to right. Therefore, atomic radius is decreases from left to right. Atomic radius from top to bottom. Let's take some examples. Hydrogen atomic number is 1. Atomic number is 1 for hydrogen. The valence electron is 1. If take lithium, is atomic number is 3. One is 2, 2 is 1. If you take sodium, atomic number is 11. 1 is 2, 2 is 2, 2p6, 3 is 1. First shell has how many electrons? 2 electrons. In second shell, 8 electrons. 2, 3, 4, 5, 6, 7, 8. In valence shell, how many electrons are present? 1 electron. Here if we observe, here how many shells are present? 1 shell. Here for lithium, how many shells? 2 cells. For sodium, how many cells are present? 1, 2, 3. Here increasing the atomic number, increases the cell. Cells also increases. Number of protons, how many here? One proton. How many electrons are? One electron. One electron. Number of protons is 3. Number of electrons 3. 3 protons, 3 electrons. 11 protons, 11 electrons are present in sodium. Here we concluded that number of cells increases, shielding effect also increases. What does mean of shielding effect? Shielding effect means inner electron repulsions. Therefore, number of cells increases, shielding effect increases, and atomic radius also increases from top to bottom. Now I explain little about shielding effect. If take sodium, it is a nucleus. First cell has how many electrons? 2 electrons. Second cell has how many? 8 electrons, right? These cell acts as a shield because these two cells are interacting more, but valence cell is not that much interact because these two cells acts like a shield. This nucleus is not interacting much with the valence shell electron, so shielding is more for these two cells. That's why shielding effect is more, but for valence electron is less. Atomic radius for p block elements. If take boron family, boron, aluminum, gallium, indium, thallium. If you write electronic configuration for this, helium 2s2 2p1. For aluminum, neon 3s2 3p1. For gallium, argon 3d10 4s2 4p1. For indium, krypton 3d 4d 4d10 5s2 5p1. Here number of cells increases, right? This is 3d 4d and 5d. For thallium, Gina 4f14 5d10 6s2 6p1. In general term, from top to bottom atomic radius is increases, right? Like boron greater than boron, aluminum, boron less than aluminum is less than gallium, indium, thallium. Boron is less than gallium, less than aluminium, less than indium, thallium. This is the correct way of atomic radii for boron family. Why? Because of here, if you observe, boron has s and p orbital, aluminium has also s and p orbitals. If coming to gallium, d electrons are present. Here if we observe, d electrons is completely filled, means lobes are diffused. D lobes are diffused. Diffused means large. Whenever d lobes are large, the electrons are easy to move. Actually, this is nucleus. The first shell acts as shielding. It protects from nucleus to second cell, right? Because the nucleus is less interact with the valence cell, because this cell acts as a shield, right? So less interact with valence cell. So shielding is more to nucleus to first cell. But here the lobes are diffused, right? So pure shielding effect. Attraction between nucleus and valence cell is more increases. So size decreases. Here we may get one more doubt. Argon also has 3d electrons. Sorry. Aluminium, gallium also has 3d electrons. Indium, thallium also 5d electrons. Fully filled 5d electrons, right? Here only increases the size is decreases, but here increases the size, right? But because here 3d shell is completely filled, here also 4d cell is completely filled, but here extra cell is added, so that's why increases the size. Shielding effect is more, so that's why shielding atomic radius is more for indium. For gallium, here also we can call it is transition contraction. Transition contraction is generally contraction happened in d block elements. Here also we observed transition contraction. What is lanthanide? What is transition contraction? This is the unexpected contraction in size of d block series is known as transition contraction. That's all for today. Thank you for watching.